Hey guys, in this video we are going to talk about graphing the square and cube root function. A little bit more specifically, we're going to add in reflections in the x-axis, which we can call vertical reflections, as well as vertical stretches and shrinks. The big idea that you need to remember is that all reflections, stretches, and shrinks must come before the translations. The reason why we do this, order of operations, you always multiply before you add or subtract. So starting with this first function, I have a negative out in front of the radical. When you're multiplying by a -1, we say that that's a reflection in the x-axis. This +2 is on the outside. Outside is always vertical. Vertical is always what we expect. So if it's plus, you would think to move in the positive direction, which we do. We vertically translate up 2. Now, if you remember, our square root function kind of takes on this shape. So when we reflect it in the x-axis, that means all the y values are going to become negative. It's then going to look like that once it's been reflected. So make sure you still kind of have that idea of what the square root function looks like, and then apart what it looks like when you've reflected it. So reflection in the x-axis means that I'm going to multiply the y values by -1. I have to do my multiplication first because of order of operations. From there, we're vertically translating up 2. So we're going to multiply by -1 in the y's. Then we're going to add 2. We're not changing the x's at all, so we just rewrite those as 0 and 1. So for our new y values, 0 times -1 is 0. 0 plus 2 is 2. 1 times -1 is -1. -1 plus 2 is 1. And we can plot our new values, 0, 2, and 1, 1. Remember, we're focusing on the reflected square root function. So instead of going up and to the right, we're going to be going down and to the right. This is also going to change our domain and range a little bit from our previous video. Remember, domain is referring to the x values. I'm still continuing forever to the right, so that's going to a positive infinity. And then your point, smallest x value, your point all the way on the left is this point here, which is an x value of 0. The range has changed slightly. I'm no longer going up forever. I'm now going down forever, which means I'm approaching a negative infinity. And then your biggest y value, your highest point on the graph, is this point here, which is a y value of 2. For the second example, we have a cube root function. So now I have 3 parent points, so -1, -1, 0, 0, and 1, 1. Negative on the outside here tells us we have a reflection in the x-axis, which means I know I'm going to be multiplying my y values by -1. This +3 is on the inside here. I know inside is horizontal. So I have a horizontal translation, and then horizontal is counterintuitive. So when you see plus, you should think to be going right, but you're really going to be moving to the left 3. So from the x's, I'm going to subtract 3. So this is what our parent cube root function looks like. It looks like this kind of stretched out S shape. If I reflect it, then this piece is now going to come down here. And this piece that was below the x-axis is now going to become above the x-axis. So now it's kind of like a backward stretched out S value. So keep this picture in mind as we're graphing this function. So the x values, I'm going to subtract 3. -1 minus 3 is -4. 0 minus 3 is negative 3. 1 minus 3 is negative 2. The y values, I'm going to multiply by negative 1. Negative 1 times negative 1 is 1. 0 times negative 1 is 0. 1 times negative 1 is negative 1. So we plot our points. Keeping in mind, I know it looks like a straight line. We've only plotted 3 points. You want to make sure you get that kind of stretched out S shape, or backwards S in this case. For the domain, I am continuing left forever, so that's a negative infinity. I'm also continuing right forever, so that's a positive infinity. For the range, I'm continuing up forever in this direction, that's positive infinity. And I'm continuing down forever in this direction, that's negative infinity. Once again, cube root function, domain and range should always be negative infinity to infinity, or all real numbers. All right, third example, starting with 2 parent points, because it's the square root function, 0, 0, and 1, 1. This 2 on the outside is being multiplied. I know outside means it's vertical. Vertical is always what we expect, so this 2 is bigger than 1. It would make you think to stretch, and we are going to stretch. It's a vertical stretch by 2. Minus 5 is on the outside. We know outside is vertical. And once again, it's what we expect, so minus 5, we're going to be moving down 5. Because both are vertical, both are going to be done to the y's. Remember, we want to stretch before we translate, because we multiply before we divide. So to the y's, I'm going to multiply by 2, then subtract 5. X values stay as 0 and 1. And we go from here. 0 times 2 is 0. 0 minus 5 is negative 5. 1 times 2 is 2. 2 minus 5 is negative 3. You're vertically stretching, which means you should be moving closer to the y-axis because you're stretching towards it. Let's make sure that that happens. So 0, negative 5. 1, negative 3. You can see that this looks like it's increasing a little bit faster. It's almost like you can think of it as being a little bit steeper than it originally is in our parent function. As far as domain, I am continuing to the right forever, so I'm continuing towards positive infinity. Smallest x value is the one all the way towards the left, which is this x value here of 0. I'm also continuing up forever, so that's a positive infinity. And then my lowest point, my smallest y value, is down here at negative 5. One final example, we have the cube root function, so we have 3 parent points. This 1/2 is on the outside. I know outside is vertical. 1/2 is less than 1. Vertical is what we expect, so I expect this to shrink my graph. It's going to. We have a vertical shrink by 1/2. This 1 here, this minus 1 is on the inside. I know inside is horizontal. And we know horizontal is counterintuitive. So minus 1, really we're going to go to the right one. So to the x values, we should be adding 1. And to the y values, we should be multiplying by 1/2. Starting with the x's, negative 1 plus 1 is 0. 0 plus 1 is 1. 1 plus 1 is 2. Multiply the y's by by 1/2. Negative 1 times 1/2 is negative 1/2. 0 times 1/2 is 0. 1 times 1/2 is 1/2. because we are shrinking here, we should be getting further away from the y-axis, which means we get closer to the x-axis, which means our S-shaped graph is going to be stretched out even further. It's going to look even less like an S shape. So 0, -1/2, 1, 0, 2, 1/2. Still try your best to get that little S shape. As far as domain, I am continuing to the left and to the right forever, which we've talked about this. It's always going to be the same, -infinity to +infinity. Even though it doesn't look like it, you are going to continue up forever to the right and down forever to the left. You will eventually hit all values from -infinity to infinity.